We're going to look at a few different kinds of trig equations and try to develop some strategies for solving. One strategy we saw in the first problem was to isolate the trig function involved. We'll now look at some equations where there might be more than one trig function involved. So how do we deal with these more complicated situations? Also, in this problem that we're looking at, I'm back to just finding solutions on the interval from 0 to 2 pi. So we don't have to describe the infinite number of solutions that there will be if we allowed all possible values of the input. We're only going to look between 0 and 2 pi for solutions for this, and really for most of our examples from now on. So let's solve for x. And you see this equation, cosine x sine x equals cosine x. So that's cosine x times sine x equals cosine x. And you might be tempted to, I know often students look at an equation like this and they want to divide both sides by cosine x. So I'm going to say do not divide both sides by cosine x if you're tempted. And I'm going to talk about that in a little bit. But first I want to go through my version of a solution, and then we'll talk about why this leads to trouble. What I'm going to do is here I'm going to get one side equal to 0. Set one side equal to 0. And what we're going to be able to do is we're going to be able to use some factoring to help us get through to a solution. So what I'm going to do is subtract cosine x from both sides. So this becomes cosine x sine x minus cosine x equals 0. So one possible strategy in all these problems is to set one side equal to 0 and factor. Now here, by factoring, I just mean remove common factors. I have a common factor of cosine x for both terms on the left. So I can factor out a cosine x times, I'll have sine x minus 1. Now there's something called the zero property we use a lot with quadratic equations when we factor. If we have a product equal to 0, then we know that either the first factor is equal to 0 or the second factor is equal to 0. So because of the zero property, we can split this factored form up into two separate equations. We can say cosine x equals 0 from here, or sine x minus 1 equals 0 from here, right? And now this little equation, cosine x equals 0, is I can solve because I'm looking between 0 and 2 pi for angles where cosine is 0. Cosine of 0, remember, is 1. Cosine of pi over 2 is 0, so x could be pi over 2. Cosine of pi is negative 1. Cosine of 3 pi over 2 is also 0, so either pi over 2 or 3 pi over 2 are possible values of x where cosine x is 0. Over here we have sine x is negative 1. That's equivalent to saying sine x is 1. So here I isolate the trig function at this point. Sine x equals negative 1 when, sine x equals positive 1 at pi over 2. And that's the only value between 0 and 2 pi where sine x is 1. Now we have a little bit of redundancy here, right? We're saying pi over 2 twice, so for our final solution, we just have to say x equals pi over 2, or x equals 3 pi over 2, and that's it for our solutions between 0 and pi over 2. Now, I want to just go back to this idea of dividing both sides by cosine x. So just call this a bit of a warning. If you take cosine x, sine x equals cosine x, let's draw a line between this. If we divided both sides by cosine, we end up with sine x equals 1, and the only solution we get from sine x equals 1 is x equals pi over 2. So we lose the 3 pi over 2 solution if we divide both sides by cosine x. Just like a general rule in algebra is if you divide both sides by an expression involving the variable, you may lose solutions. So never divide both sides of an equation by an expression involving x. That's just almost always going to lead to trouble. Seems like a good idea, but you're throwing away solutions. You're throwing away solutions where that quantity you're dividing by might be equal to 0. Okay. All right. So that's what we want to remember, is what's up there. And there were 2 solutions to that equation. Let's go on to another example. So let's solve for all exact solutions on 0 to 2 pi. So we're just looking from 0 to 2 pi again. And we're working with this 2 cosine squared x equals 1 plus cosine x. So the good news is I don't have a sine and a cosine. I just have cosine. The complication is I have cosine squared and cosine. Ultimately, I'd like to isolate the cosine if I can. What I'm going to do here is kind of similar to what we did in the previous problem. I am going to get one side of this equation equal to 0. So I'm going to rewrite this as 2 cosine squared x minus cosine x minus 1 equals 0. So I get all those terms on one side. And then the technique we can apply here is we actually can factor this left-hand side, just like a quadratic. If you now I'm going to just pick a symbol out of the blue here. If I let a equal cosine x, okay, that equation looks like 2a squared minus a minus 1 equals 0. We say that's a quadratic in cosine. 2a squared minus a minus 1 well, we can try to factor it. Let's see. 2a and a, and I'm going to have, let's see, if I write plus 1 minus 1 to get negative 1, check the outside, negative 2a plus 1a is negative a. That actually works as factoring. So because I can factor this trinomial with a, I can factor the trig equation with cosine. I can say this factors as 2 cosine x plus 1 times cosine x minus 1 equals 0. And you can check this multiplication using FOIL just like you could with A. 2 cosine x times cosine x is 2 cosine squared. Outside we get minus 2 cosine x. Inside plus 1 cosine x is minus cosine x. And the L of FOIL, 1 times negative 1 is negative 1. If we're able to factor this, and we have one side of this equation equal to 0, by the 0 property, I can say either 2 cosine x plus 1 equals 0, or cosine x minus 1 equals 0. So my big equation is split into two less complicated equations. And then in each one of these, I want to isolate the trig function. 2 cosine x is negative 1. So here cosine x is negative a half. Or over here, cosine x is positive 1. Once I get the trig function isolated, then I just have to work through this in my head. I can think about the unit circle or refer to the unit circle if that helps me to find solutions between 0 and 2 pi. Let's see, for cosine x equals negative a half, so that's like a negative a half x coordinate on the unit circle. There's going to be two possible solutions, right? This one and this one. Now I know cosine of pi over 3 is a half. That's actually the reference angle. So from here to here is pi over 3. That means this guy is 2 pi over 3, right? And the other solution is going to be pi plus pi over 3, or 4 pi over 3. So I get x is equal to 2 pi over 3, or x is equal to 4 pi over 3 from cosine x equals negative a half and a little bit of unit circle analysis. Cosine x equals 1, I think that's just going to be x equals 0. Cosine is 1 here, 0 here, negative 1 here, 0 here. Now we don't have to write 2 pi. If you accidentally wrote x equals 0 or 2 pi, we're not going to take off because 2 pi is also a solution. But our textbook likes to leave off the 2 pi, so they're kind of saying if you give me the 0 solution, you don't need to give me the 2 pi solution in this 0 included, 2 pi not included interval notation. So I think here are our solutions. X equals 2 pi over 3, 4 pi over 3, or 0 are the solutions to that equation.